Good evening, everyone. Welcome to the Caithness International Science Festival. We're delighted to welcome you to this evening's presentation, Exploring Offshore Wind Around the Coast of Caithness. I'm Claire Gallagher, Science 03 committee member. Joining me tonight is Nicola MacLeod, our festival coordinator, and our chairman, Ian Bakey. So before we begin, a little bit of housekeeping. This event is being recorded, but your screen is not. So if you've minimized me to play Minesweeper, don't worry, we can't tell. This has been a very popular event. No pressure, Magnus. So can we please put all comments, feedback and questions through the Q&A, and we'll answer as many as we can. Now, as an audience, you can actually upvote the questions that you think you would like to be answered quicker, so they go to the top of the queue. So yeah, just move that up the list if you're interested. Our presenter this evening is Magnus Davidson, a full-time researcher with the Environmental Research Institute in Thurso, who specialises in investigating the interactions between the environment, the economy and society. Magnus is also famous among the local press as Far North Man, as in Far North Man becomes Director of Community Land Scotland. Magnus was also a founding member of the 2050 Climate Group, an environmental organisation that empowers young people in Scotland to act on climate change. This evening, Magnus is going to explore the offshore wind potential found around the coast of Caithness and discuss how new and existing developments can benefit us at a local, regional, national and international level. So with that being said, it's over to Magnus.
Perfect. Good evening, folks, and thank you very much, Claire, for that fantastic introduction. I'm just going to start sharing my screen. Hopefully you can all see that. Yep, hopefully a thumbs up. Perfect. So this is a topic that's actually quite close to my heart. I have a huge interest in energy, huge interest in Caithness. So let's add the two together and talk about them for hopefully around 40 minutes. I'm going to try to keep the time as best as I can. Just two quick slides as ways of introduction. I work for ERI. You might know us, you might not. We're based in Thurso. We're part of North Highland College, which is part of the University of the Highlands of Islands. We're based across two different buildings in Thurso. One's the Old West Public School in Castle Street, and one's the big wooden building attached to the college, which is the Centre for Energy and the Environment. We want to be internationally recognised for distinctive and innovative environmental research, and I think we do quite a good job of that. Myself, I have been studying energy, offshore wind, marine renewables, wave, tidal, onshore wind for probably the last 8 years now, with a real focus on the Highlands and Islands. It's largely the area where most of my research is focused. A lot of that's to do with not actually the environmental side of things, but the social and the economic aspects. And I will kind of look at the wider social economic aspects of lots of different developments in the Highlands and Islands. Anything to do with Caithness, I'm just fascinated by and really enjoy working on. But energy is a common theme across them all. To make use of the pictures, I actually grew up on the Black Isle in Cromarty, which looks out across a lot of oil rigs and now new turbines, but we'll kind of get to that later, but hopefully also gives you an idea of why I'm interested in these topics. So to begin with, I'm going to start with the story of offshore wind in Caithness or off Caithness. I'm going to explore it in a kind of like a timeline manner, beginning with the Beatrice demonstrator, but I'm also going to take in slides to explore issues around jobs, impact, where these jobs are found, developments at Wick, for example, but we'll go kind of a linear timeline through. So the Beatrice demonstrator was the first offshore wind farm I ever became aware of, largely because I grew up in the town of Cromarty and watched it being built, and like the picture on the right-hand side at Nig. It was very new at the time, and I was just really, really interested to follow. So this is a familiar site for Caithness residents because we've been looking out over it for a great number of years. It was the two turbines, or is the two turbines, just off the Beatrice platform. This was a joint project between Talisman, who operated the Beatrice field, and SSE, to demonstrate large turbines in deep water. It hadn't been done before, This was to test out putting them on these big steel jackets, putting them out quite deep at sea. However, unusually, this was providing electricity to oil platforms and not to the grid. It wasn't actually connected to the grid. It was just providing electricity to these platforms. As I say, they were assembled at NIG, which will become a theme of this topic, but they were 2 5-megawatt Senvion turbines, so kind of slightly larger than we would see onshore, but certainly not the massive turbines that we are seeing today and probably will see built out in the future. They were commissioned in 2007. They were actually built the previous year, and one of them came a bit later than the other because of some bad weather, and they're due to be decommissioned pretty soon alongside the Beatrice platform. The reason they weren't incorporated into the wider or the bigger Beatrice project was they're different turbines, they're older technology, they're not connected to the grid, so it would have just been too much bother and too expensive to keep them going out there. I recently read and reviewed a fantastic book, a short history of wind energy in Scotland, and there was an account of this relived in the book. And I thought it was really interesting because one of the quotes in there said Beatrice gave the next big kick to offshore wind after the Danes had started to put much smaller turbines out at sea. So all the offshore wind in the world really can kind of trace its steps back to what was demonstrated just off the Caithness coast over the last kind of 10, 15, 20 years. Moving on, and I just have noticed the mistake, it's not the Beatrice demonstrator, it's the Beatrice Offshore Wind Farm, otherwise known as BOL. This is, we're all familiar with this, or I would hope we're all familiar with this now. We see it a lot, we saw it being built out, we've read it in the newspapers an awful lot. So this is Scotland's largest offshore wind farm, and it's actually the world's fourth largest offshore wind farm. It was built over a number of years, between 2016 and 2019, and its operations base is in Wick Harbour. We'll get to that a little bit more in later slides, but it's just to say how fantastic it's been to see it being operated out of Wick. Bear in mind some of these figures because they'll be quite relevant going forward with other slides. But this is a wind farm composed of 84 7-megawatt Siemens turbines, so slightly bigger than the demonstrated turbines at 5 megawatts, but these days maybe not as big as we'll be seeing elsewhere. It's owned mostly by SSE, or the largest shares SSE, the old hydro, also Copenhagen Investment Partnership and Red Rock Power Limited, split between these. These are hugely expensive projects, and you kind of need to share this across a number of partners in a lot of cases. Who are CIP and Red Rock Power? These are people that look after kind of pension portfolios and such like. So there may be, your pension maybe even be tied up in Beatrice Offshore Wind Farm. There's a total of 588 megawatts here, which is quite a big development, but not as big as we're going to be seeing elsewhere. That £2.5 billion price tag is an incredible sum of money. It's almost twice as big as what the new Queensferry crossing cost. And I was always pointing this out to my counterparts in the Central Belt who were talking about the new Queensferry crossing being such an investment in the country and a massive price tag. I was saying at the time, look, we're building something a lot bigger and a lot better here in Caithness. And alongside the Caithness-Murray connector link and the grid infrastructure, we were almost seeing 3.7 billion being spent in the Murray Firth at one period of time, which is just incredible sums of money. That 2.6 billion is one of the largest private investments in Scotland ever. We hear a lot of criticism at times, I think that's fair to say, or a lot of comment at times around how much of this is actually being spent in Scotland, how much is being spent in the UK, and how much is going overseas to other companies or companies based out with the country. So here's a nice wee breakdown, and I think this was, I can't quite remember who did this study. I'll need to go back and post it into the comments or something. But anyway, you can see a nice breakdown. DevEx and CapEx is just the amount of money it takes to develop and build the infrastructure itself, build the development itself. OPEX is how much it costs to operate and run. TOTEX is these figures put together. So you can see if we just cut straight to TOTEX, the total amount of money spent over the lifetime of the project, about 40% is in Scotland, about 62% is in the UK, and obviously 100% over elsewhere. Beatrice was quite good in that it built some of the jackets here in Scotland between Bifab and Fife and Arnishyard, also owned by Bifab and Lewis. And we've probably not seen some of the as good benefit from offshore wind with some other wind farms being built in Scotland. So it's just I think these are fantastic figures to give you an idea of how much money is actually being spent here. It's just unfortunate we can't break it down to Caithness itself. So I've titled this slide Lucky in Time and Place, and I'll get to that again in a later slide. But what we've seen in Wick at the harbour front is just fantastic. 100 long-term jobs, restoration of these amazing Telford buildings, the port upgrades in the harbour itself, the investment in the airport for the helicopter. It's just been amazing to see, and I think hopefully everybody would agree the transformation that's been seen at Wick Harbour has just been really, really good. Fantastic for the town, fantastic for the county. Even in this, what's interesting is when they were advertising for jobs for this, you needed to be located within a certain, or willing to relocate to, within a certain distance of Wick. So they made a real effort to make sure that the jobs, or some of the jobs here, were local. The reason I say lucky in time and place is that in some of the larger developments, perhaps going further afield offshore, what they're moving to is bigger vessels that kind of stay out at sea for longer periods of time, rather than cutting back and forth every kind of day. So Claire alluded to the fact that I was a director of Community Land Scotland, another passion of mine, but this is what I keep trying to point out to people, what I think is a world first, in that community benefit money from the Beatrice Partnership Fund, from the Beatrice Offshore Wind Farm, actually was used to help buy out some land, the Garvault Estate in West Helmsdale. So for the first time in the world, I think, I would happily be corrected on this, the community here in Scotland and East Sutherland used the offshore wind resource and the accrued benefit or monetary benefit from that to actually buy out its own land. I think it was just absolutely fascinating, and everybody involved there should be commended for that. Of course, there's questions about how much money is generated from these kind of wind farms and how much actually makes it to the community, but I think we need to celebrate successes like this when they happen. So again, I alluded to Nigg earlier on, and I thought it would be nice to kind of just diverge away from Caithness briefly here to discuss what's been going on in Easter Ross and Cromarty Firth, largely because of the connection now with Caithness. And I should say not just with offshore wind, but also tidal power. Maygen are based or have their operations and maintenance base at Nigg alongside CIMIC Atlantis, who actually are going to be building tidal turbines there to go across all across the world. But Nigg is historically an oil and gas fabrication yard. There was also a separate oil terminal owned by Talisman for the Beatrice oil field, and it's part of a much wider Inner Murray Firth cluster, including the port of Cromarty Firth and a lot of oil and gas companies based in the Cromarty Firth and wider Inner Murray Firth area. Global Energy took over the site in 2001. It actually became mothballed in, I think, around the year 2000 after the Elfelgan was built. But ever since then, they've just been investing in that yard. So they invested 50 million in new port infrastructure, new South Quay, and they've invested in 40 million in heavy plant, particularly for the offshore wind sector, kind of heavy lift vehicles and such like, to be able to shift these big towers about. In the top image, you can actually see one of the big cranes. The bottom is Port of Cromarty Firth as well. They've also been heavily investing to be able to capture some of this offshore wind market. The they've been actually really successful at it too. And one of the lessons that I think Scotland can take from this is that you need to invest in your yards to be able to capture this benefit. We've not seen that investment in yards further south in Fife at BIFAB, and they've lost out because of it. And yeah, you'll see from this that they lost out from it. Offshore wind's been quite controversial in Scotland and Scottish context for the amount of benefit that has been captured for local communities, local businesses, regional companies. So I've shared a range of news topics here dealing with this. So in terms of other offshore wind farms not using local yards or Scottish yards to build these jackets, Scotland doesn't have a manufacturing or capability, or doesn't have companies who actually build the turbines themselves. Some of the vessels, or all the vessels used, are registered elsewhere with other companies. And a lot of these big tier 1, tier 2, even tier 3 supply chain companies are not based in Scotland. So Scotland, the Scottish government, the UK government have come under quite a lot of criticism for not ensuring that all the benefit that could be captured in building out these wind farms has been captured. However, on the right-hand side, I've alluded to floating offshore wind as well as the Kishorn Yard in Westeros around potential for capturing more benefit. One from floating offshore wind, which is more of a nascent technology, as well as new yards or old yards rejuvenated like Kishorn for building new kind of structures. We also have some really quite cool news, hopefully in the running. There's actually plans for the UK's largest steel rolling mill wind fabrication plant planned for Nigg. This is a state-of-the-art advanced manufacturing facility which will build the steel towers, the foundations. We're hoping to get some news on that over the next couple of weeks. The Scottish government and the UK government are just trying to come to a funding arrangement with Global Energy Group to be able to get that in place. Not to be left behind, the Port of Cromarty Firth as well. That's the Port Authority over the whole of the Cromarty Firth, signed partnerships and MOUs around floating offshore wind, developing concrete bases for the floating offshore wind sector. The Port of Cromarty Firth is actually looking for free port status, or green port status as it could be known in Scotland. And there's a consortium there between many of the players involved, as well as UHI, the Highland Council, looking at developing this to be the hub in not just Scotland, but the UK for floating offshore wind. And lots of other really interesting proposals around green hydrogen, and yeah, lots of really cool stuff. So there's really nice stuff on the horizon. As we move to the next wind farm being built out in Caithness, the Moray East wind farm, you'll see the jackets at Nigg started to arrive, I think, last year, and maybe just the start of this year. This is a development that's going into the east of Beatrice. It's being built now, and you'll probably maybe just be able to see some of the vessels out behind Beatrice if you look on a clear day. And I was saying to kind of keep an eye on some of the numbers involved. Excuse me. And I've kind of put the Beatrice numbers here in brackets just for reference, just for context. This is going to be 109 megawatt turbines as opposed to 84 7 megawatt turbines, with a total generating capacity of 950 megawatts as opposed to 588 megawatts. 950 megawatts, for example, is probably what one modern nuclear reactor might look like in terms of output. Although, of course, with offshore wind, you need to be the wind needs to be blowing at quite a speed to get that full capacity out. I was actually just reading that the capacity factor for a floating offshore wind farm off Aberdeen has achieved some of the highest capacity factors in Scotland, in the world, around 57%. So what's really interesting between Beatrice and Moray is the cost of electricity per unit of electricity that it's going to be pumping out. It's generating power at £57.50 per megawatt hour, as opposed to the £140 per megawatt hour for Beatrice. This is just an indication of how quickly the price for offshore wind has dropped largely through scalability, lots of minor incremental benefits, technological innovation accruing from that. So the price of offshore wind has dropped drastically and is really looking fantastic compared to other sources of generation. Just for reference, the strike price, which is kind of comparable to this price for the new Hinkley Point C, I think I'm right in saying, nuclear power plant is £92.50. So you're almost half the price as nuclear power these days for offshore wind, although it's still intermittent. The operations and maintenance base here is unfortunately from a Caithness perspective in Fraserburgh, but still good for Scotland. These will probably be using larger vessels, which is why I was alluding to the fact Wick might have been lucky in time and place with Beatrice. Moray West is part of a much bigger wind farm, or half of a much bigger wind farm. They've split this off into two to make it more manageable to develop, and Moray West is also going to be built out. It's been consented, so they've got planning permission, planning consent, but they don't have a subsidy mechanism or a support mechanism in place, which is called a contracts for difference. However, this year, the CFD realms will be going into play, and we can maybe pick this up in questions if you're interested in how this works. But we'll probably know a bit more in the next year if it wins a contract and when it might be built out. However, they are actually doing a lot of survey work out there at the moment, so they must be quite confident that they can build this out. Moving on to the next one, and this isn't built, but it's been kind of covered in the news quite a lot, and it's been in the Groat quite recently. This is the new, I think I've got lots of stuff on my screen, so I can't quite see. It's changed its name a number of times, the Pentland Demonstrator or something. It used to be known as the Dounreay Try development. So this is around 10 k's off Dounreay. It's 6 to 10 floating wind turbines. So instead of being on a fixed base that's attached to the seabed floor, it's on a floating structure that's effectively just anchored with some really good anchors to the seabed. And these turbines are probably going to be between 10 to 16 megawatts. I suspect probably closer to 10 megawatts, but it just shows how these turbines are getting bigger and bigger. It's also why the price is coming down. The bigger the turbine you have, the better it is at capturing the energy, and that price per unit of electricity starts to fall. It will be around 100 megawatts total capacity, or will be 100 megawatts total capacity. And it's actually been developed by one of the same people involved with BOL CIP. I did say it builds on a previous project, the Dounreay, Try project, which ran into financial difficulties. Unfortunately, however, this might just be coming back a little bit bigger and a little bit better. These turbines could potentially be quite big though. Beatrice are around 188 meters, and these could be anywhere between 192 to 270 meters, depending on whether or not they'll be that 10 to 16 megawatts. There's obviously quite a lot of concern here about visual impact. I think that's perfectly reasonable. It'll be interesting to see what the visual representation here comes back, because it's quite a nice seascape out there to Orkney. But we'll maybe address some of those concerns around visual impact a bit later on. So then we move on to the potential new wind farms that are currently being bid on. This is kind of covered in the sectoral marine plan put out by the Scottish Government relatively recently. I think it was just the end of last year. It identifies future commercial scale offshore wind farms. When I say future, they're probably being built out sometime over the next 10 years, maybe creeping into the start of next decade. It includes deep water wind technologies. So what we mean by that is effectively just floating wind out at deeper water. Once the water gets too deep, it becomes too expensive and too much of it. I think an engineering challenge to get fixed bed turbines on the seabed. So the floating wind turbines really come into their own there. It aims to minimise potential adverse impact on other marine users. We can't just pretend because they're at sea, they're out of sight, out of mind. A lot of people use the seascape, a lot of people use the sea, whether it's fishing, whether it's ferries. whether it's even just recreational sailing. And it also aims to maximise the economic development in Scotland. So some of the criticisms of those earlier wind farms, it really seeks to address some of those by maximising the local supply chain or the Scottish supply chain in those. As you can see from the really nice map on the right-hand side, this does mean new offshore wind farms planned for the waters around Caithness, that little bit further offshore in both the north and the northeast sector. So just to run through some of these to give you an idea of the scale, because these the polygons marked on the map are not representative of scale. North number 1, which is kind of off the north coast, perhaps more so off Sutherland and Caithness, but I've included it here for the sake of, because I think it might well just creep into some of Caithness water. It's looking at potentially a maximum of 2 gigawatts, so effectively almost twice the size of Moray East, or probably around 4 times the size of Beatrice. Northeast 2, which is off Orkney a bit more, but still probably within sight of Caithness and a nice clear day, looking at around 1 gigawatt. So again, twice the size of Beatrice. You can see that's kind of fair going into Northeast 3 and Northeast 4, which is Northeast 4, that bit further east from Moray East and Moray West, as well as Northeast 3, that little bit further. I was speaking to a few of the guys in the industry, and I suspect most of, if not all of these, have been identified as floating offshore wind because of the water depth. But I wouldn't quote me on that, because somebody might come along and decide they want to try and do it fixed. But I suspect they'll all be floaters. Just to give you an idea of why you shouldn't trust the visual representation on this map, if we look at E1, which is kind of off the coast of Edinburgh, or I don't know if that's even fair, that's what I would call it. It looks massive, but it's actually just an inch of 3 gigawatts, only utilising 16% of that area. So it's just to give you an idea of what the numbers are involved and where they are. It's looking like we could really increase the size of offshore wind found off Caithness. So what does this mean for Caithness? It's incredibly difficult for me not to see benefit accruing to the county because of this offshore wind, largely due to the proximity of, for example, the port at Scrabster, also Gills Bay, although I suspect there may be more looking at the tidal sector, as well as Wick. Wick showing that it can act as a fantastic operations and maintenance base for offshore wind. And Scrabster's just it's had so many years now of the renewable energy sector, the oil and gas sector. It would be really difficult for me to not see companies using these ports. There's an increased demand on the developers in the ScotWind leasing round. So the ScotWind leasing round is currently ongoing, and it's effectively where the government auctions off the seabed to developers to come in and then to develop offshore wind farms. What was really interesting was that the English example has just happened, and they were absolutely staggered by the amount of money being offered by developers to develop the offshore wind farms. So much so that the Scottish government put hiatus on their own ScotWind leasing round to reevaluate if they got it right. The results of that just came out today, and it looks like the government wants more money for their seabed, and they want more local supply chain content for leasing that ground to the companies. So that's quite a good thing for Scotland. It might mean new upgrades to ports if companies are wanting to come in and use these ports as their O&M bases. It might mean a lot of money coming in to upgrade these ports. Certainly mean new jobs in the county, whether it's jobs found at the ports themselves, or if the companies meet these local supply chain demands and use local companies, or require that the folk working on these wind farms are required to live within certain distance of the ports. I think 35 miles is quite often used. Also, how about this transition from oil and gas? Like myself, I presume you all know a lot of people working in the oil and gas sector in the county who go away for 2 weeks at a time, 3 weeks at a time, maybe even longer. However, this might be an opportunity for these people to transition away from the oil and gas sector as it naturally declines in the North Sea and further afield. and move into these well-paid jobs that utilise the skills, the skill sets, the training that they already have. However, there's always the negatives. Usually they try and reduce the environmental impact. Sometimes these structures can even offer a reef effect. So if you exclude fishing for some areas, for example, it means they become really good breeding grounds and actually improve the fish stocks elsewhere. However, there's always an associated visual intrusion with offshore wind and onshore wind. Luckily, with offshore wind, it's out at sea, but if you put them out at sea, you can put bigger turbines in, which increase the visual intrusion. So we shouldn't shy away from the fact that even as proponents of this industry, like myself, we need to acknowledge there's a visual intrusion here. We need to acknowledge that a lot of people don't like that visual intrusion. Again, we'll deal with that in a couple of slides. And that's us actually getting to them. So one of the comments that we hear an awful lot here in Caithness is that we produce more electricity than we need to from renewables, and we send a lot of that south. And it's totally true. I don't have, or the statistics don't go down low enough for Caithness, but we can get them to a local authority area, so Highland Council area. Again, a lot of issues there, way too big in my opinion, but that's probably worth an hour's discussion on a different day. But Highland produces over a quarter of Scotland's renewable electricity. You can see on the map here, you can visually see it there, well beyond any other local authority area. Dumfries and Galloway come close, I think, in a second place, something like 12%. We're really the powerhouse of Scotland. We produce huge amounts of renewable electricity. We actually produce over 420% of our own electricity demand. So for every 1 unit of electricity that we require in here in Highland, we produce 4 times as much than we use. We often hear about Orkney being fantastic, producing more electricity than they use from renewables. They're probably at around 126 or around just over 100%, shall we say, depending on what year it's been. So we do a lot better than Orkney, which I think is quite nice here. Yeah, these are the statistics to local authority region, but at a county level, I think it's pretty fair to say that we export a lot more renewable electricity than we use. To use an example from onshore wind, this is kind of a back of a fag packet calculation that I did, but I suspect in the month of May, Bailey Wind Farm produces enough electricity to power the whole of Thurso for a year. So with figures like that, you can see that we're exporting a lot of electricity. We're also pretty close to 100% of our electricity consumption in Scotland being met by renewables. In the year 2019, we're just shy of 90%. The reason we're in 2021 and we're not talking about if we've achieved this target is because the statistics take a long time to compile, excuse me again. And so we're always a couple of years behind with the statistics. But we're pretty close to 100% of our renewable electricity, or our electricity being from renewable sources. You can see a breakdown there, onshore wind, offshore wind, hydro, and stuff like. So yeah, it's a staggeringly good statistic. However, electricity isn't just the only type of energy that we use. If we're talking about all the energy that we use, we're barely making 1/4 of our energy consumption being from renewables. We're really failing on heat and transport. So for example, a lot of us, in my house, I use electricity, but in rural areas, we use a lot of heating oil. In bigger towns, bigger cities, we use a lot of natural gas to heat our homes. Trying to make that renewable is going to be a real challenge. Same with transport. We all drive petrol and diesel cars, although electric cars are obviously coming into their own a bit more. But our trucks, our ferries, our airplanes are all fueled by fossil fuels. So how do we get from that 24% to 100%? How do we make renewable transport and heat renewable? We need to use electricity. There is some discussion around carbon capture and storage, but the easiest way is, there's no easy way, but the way that we're probably looking is that we're needing to use electricity. So that's things like heat pumps, new good storage heaters, not the poor old type that we come to know. It means electric cars, it means electric trains. We're currently working on a project at UHI looking at electric and hydrogen planes. Hydrogen's one, so we hear about green hydrogen as a solution to a lot of our challenges. To make green hydrogen, we need electricity, we need renewable electricity. So we need to start to increase or even increase our generation a lot more. What's really interesting, or I think is really interesting, is when we start to look at some of these numbers. I've taken this from a study done by SSE, looking at the north of Scotland. So if you look at the map, effectively the area under number 1, and it looks at different scenarios of how we achieve net zero in the region, or wider region, the area that SSE covers. You can see the green economy and the green society being the two that achieve net zero, the decelerated transition not achieving net zero. At the bottom, you can see the amount of renewables, renewable electricity that will, capacity that we'll need to achieve this. And at the very top, you'll see what we've already got installed. So we've currently got just shy of 8 gigawatts installed. And to achieve net zero, we're going to have to increase that to around 25 gigawatts. Even if we don't achieve net zero being we sequester, we store, we take in through stuff like trees and peatlands as much carbon dioxide as we emit. But even not to achieve net zero, we still need to radically increase the amount of renewable electricity capacity that we've got. So these numbers are really staggering, and there's no point trying to shy away from that. These are really big numbers, but the challenge that we've got ahead of us is just it's quite a challenge, quite transformational. We can't shy away from that. So before I get to the last slide, do we need to build more offshore wind here in Caithness? The answer is absolutely yes, if we want to achieve climate change goals. What I would say though is that all of us here in Caithness need to be demanding a better deal from this. We need to be putting pressure on our politicians. We need to be putting pressure on our governments and saying, look, we're an energy-rich region, an energy-rich county. We know we need to build more renewables here, but we want to get a fair deal from it. We don't want to be paying higher prices of electricity. We might actually be wanting to pay lower prices of electricity. We need to try and look at reducing that visual intrusion as much as possible. We need to be looking at reducing the rates of fuel poverty. If we're going to be exporting electricity out of the county, we want something back for it. But with that understanding that for the global challenge of climate change, we really need to be building more renewable and more offshore wind here. And that's actually it from me. Hopefully I've kept the timing's not bad. I think I've a couple of minutes early. But I would be really happy to take questions on this, not just offshore wind, onshore wind as well, the tidal sector. A lot of these kind of answers might be appropriate, not just for offshore wind, but onshore wind, the tidal sector. Yeah, more than happy to answer any of the questions that you've got, and would thank you all for coming along tonight as well.
Thanks very much, Magnus. This is Ian Beggy, one of the panel members. The first question is from S. Ward. Why don't floating offshore turbines capsize when it's very windy and rough?
Brilliant question. Do you know, that's exactly what I thought when I first heard about floating offshore turbines. This sounds absolutely bonkers, totally bizarre. But what they do is they put a lot of weight into the bottom of them. The easiest thing that you can do is get a plastic bottle in your bath and try and get the plastic Coke bottle to sit upright in the bath. You won't be able to do it. However, if you half fill that bottle with water or sand or anything heavy and then set it in the bath, it'll float, it'll bob, it'll sink down, but it'll float. That's how they do it with these offshore these floating turbine bases. They put a lot of ballast in them and then they anchor them down. The amount of weight that goes into them is just incredible. But yeah, that's how it works, and quite a nice experiment to go back to.
Thanks, Magnus. The next one is from Vicky. She's got a couple of questions. I'll read the first one out. I would like to know about the life cycle. What is the lifespan of the average offshore turbine? Are they recyclable after a lifetime in the sea air? And could this be handled with the size of them? And her follow-up question is, once the turbines reach end of life, will they be replaced in situ?
Two excellent questions as well. I'll give you my best answer that I can. So we quite often see on kind of like Facebook and a lot of social media, these pictures of these graveyards is probably the best term, of these wind turbine blades being buried in America under sand. And that's not what happens these days. The technology is increasing so that everything can be recycled. The fiberglass, which is really hard to recycle in wind turbine blades, they're looking at or developing ways for that to be recycled, repurposed. But I'm not going to lie, this is a new industry. It's not been done before. It'll probably be 20 years in a lot of cases until we have huge volumes of these needing recycled. But yeah, there's no way that these won't be recycled. The scale of this industry means that they need to come up with technological solutions. We're seeing it with onshore wind as well. So yes, they will be reused, recycled. They will. It would probably be unfair for me to say 100%, of maybe little bits here and there, contaminated bits, would go to landfill. But for the life cycle, they will be recycled. The second part of the question is again really interesting, and we can look to onshore wind as an example here. Once wind farms are consented, they largely, the understanding is that they're consented in perpetuity. I always struggle with that word. I had speech therapy as a bairn, so some words I struggle with. But effectively, yes, once the wind farm's built, the idea is that it will probably be there for a long time until we come up with something better. But they will be repowered. So by repowering, we mean putting new wind turbines once they come to the end of their life, usually between 20 and 25 years. The benefit here is that wind turbines are getting a lot more efficient, a lot better. So what we can do is we can replace, for example, an old wind farm with 10 different turbines, these days with maybe 3 or 4. If we're prepared to go bigger, we can maybe even reduce that down in size. And that's probably what we're going to see when we go offshore in 20 years, 25 years. We'll probably see bigger turbines going out at sea, but we might see a reduction in those turbines. That's also dependent on things like visual intrusion, whether or not we're, as people, as society, are happy with that. So we might say, no, that wind farm's pretty close to shore. We're only prepared with wind turbines up to a certain size. So yeah, two fantastic questions. Hopefully I've kind of answered them okay.
Thanks, Magnus. So Vicky, Magnus said that the lifetime of the turbines is 20 to 25 years. Jill would like to know about the sectorial marine plan slide, and it showed potential areas for development, but the map is fragmented. Why is this? Why are they strange shapes?
Yeah, so this is just to break it down into different sectors to manage these different sectors. It's a really good question. It's like we break down oil and gas sectors. It's just to make it more manageable in terms of the logistics and the bureaucracy behind them. I wouldn't read too much into it, other than we just break it down into categories to make them easier to manage from administration point of view.
Right, thanks, Magnus. Richard would like to know what the speed limits are for wind turbines. Do these differ between offshore and onshore?
Excellent question. I don't know the answer to, but I suspect the offshore wind farm, the blades will be traveling at a bigger, faster speed because they're bigger. But I don't know the answer to that question.
Oh, okay, thanks. Jill Ross would like to know, will tidal power eventually replace wind?
Again, really good question. I suspect it won't replace wind. We'll see tidal power in conjunction with wind. The two main renewable energy resources we have on Earth are solar power and wind power. Currently, with the terms of the technology that we've got, tidal has a key part to play in our energy makeup, particularly here in Scotland and particularly here in Caithness. But at the moment, the way that we capture tides or tidal power is where the tide speed is increased by being squeezed between islands effectively in the mainland. So that's why we have them in the Pentland Firth, because you're squeezing these two big tides between the North Sea and the Atlantic between this small space, and it pushes the speed up. Much easier to capture the tides when the speed's higher. The other way is to build massive big dams out at sea, barrages, tidal lagoons, and physically force that water into a much smaller space by using man-made structures. Hopefully, as time goes on, we'll get better at capturing these lower speeds, but it's not technically feasible to extract a good enough amount of energy from the seabed by just popping them out anywhere where the tide speeds aren't increased. So we couldn't just pop loads of them out underneath the sea in a normal area and extract enough energy from them.
Thanks, Marcus. So in summary for Jill, will tidal power eventually replace wind? Probably not then.
Probably not, but it'll help to help in the long run.
Okay, thanks. Can I also invite attendees, if they would like to leave comments or feedback on this talk, please give us that and I'll read it out to Marcus. And also the Science Festival organisers would like some feedback on our first virtual festival. So if you've got any comments about the virtual festival and the presentations, please add them to the Q&A. Thank you. David would like to know, what are the main environmental impacts documented from offshore wind?
I think that the main one that I'm aware of, and it might just be because a lot of my colleagues work on it, is that, and again, this is a word I struggle with, ornithological, so effectively the impacts on seabirds. These, again, we shouldn't think that because these turbines are out at sea, there's no impact. A lot of seabirds use these environments to live. So we actually saw one of the wind farms, offshore wind farms down near Edinburgh, get wrangled up in court for years and years because the RSPB said that they would disproportionately affect a seabird population down there. This is one where this is new technology, these are new developments, we need to monitor them as we go along the precautionary principle. But the main one for me, I would see, would be seabird interactions. There's also a lot of discussion around marine mammals during the construction phase. So the way that you pin a lot of these big structures to the seabed is you use pile driving. You effectively use a big nail and you use a big pneumatic hammer to whack them into the seabed. It creates a huge amount of noise under the sea, and that can affect marine mammals, things like whales, dolphins, and they move and communicate in a certain way, and the loud noises can really impact on them. Our colleagues at Aberdeen University in Cromarty, they've been doing a lot of work on this when Beatrice was being built, and we think, and again, I'm happy to be corrected on this, but we think that these kind of marine mammals just avoid these areas when they're being built, and they're only being built for a certain period of time. So yeah, that's another impact, but they may also have positive environmental impacts. You remove fishing from an area, it could increase the fish stocks. You also create an artificial reef with all these substructures where marine life grows. That attracts in fish, attracts in bigger fish, goes up the food chain. So they can also have a positive environmental impact.
Thanks, Matt. Thanks,
I'll just add one wee bit, if that's okay. What I have, in terms of environmental impact, I'm really bad for saying the best environmental impact from all these things is low carbon electricity and reducing that impact on the climate.
Okay, thanks. We've got some feedback. Audrey would say, well delivered webinar, very informative. Thank you very much. David Orr said, really interesting, informative presentation. Thanks, great virtual festival. He's attended 4 webinars. Question from Yoni, who is campaigning for the county to bring jobs from these big offshore wind projects to Caithness and not to larger ports further afield? Do you know if any action groups supportive or supportive MSPs and MPs?
Really good, again, really good question. I don't know of any action groups, but I think that would be a really positive way to try and bring jobs here. I think what's really, I think when the community comes together like this to not even just protest things, but to campaign in a positive manner for these kind of things, it reflects really well on the community, on the county, and politicians take that really seriously. In terms of who's campaigning for the jobs to be here, I think most politicians are to different degrees. I know that, yeah, I think most politicians would be very happy to see jobs coming here and campaigning for here. But I think an action group is an incredibly good idea and one that I would support.
Right, thank you. David would like to know, has there been a study on the impact on the quantity of electricity demand as more cars become electric, and the amount available for exporting to other parts of the country from wind farms in the Highlands?
There's been a lot of really interesting studies by people way smarter than I can comprehend, with the most amazing computers and the most amazing analysis done on these kind of things. It's almost as an art as much as it is a science, but there is a huge amount of modelling done on what the impact of more electric cars might be on the grid system, when's the best time to charge them, even if that transfer of power can go two ways. So we spend all our night with our electric cars plugged in, charging them up on cheap electricity, because nobody's using it during the middle of the night and the wind farms are all still going. However, it comes to 5:30 in the evening and we all drive home and plug our cars in at home, and we all start cooking dinner on our electric stoves and electric cookers, and the electricity demand goes sky high, and the wind turbines maybe aren't going as much because it's not as windy. We can actually use the batteries in the cars to reverse that flow, and the people who own the cars might even get a much higher price for that electricity because it's in much greater demand. So it's also to think about it in that way, that the modelling can be used in good ways, both ways. In regards to the electricity demand out with the Highlands, or out with the Highlands and Islands, out with Scotland, I've not seen a huge amount done on this, but there's some really there's a lot of people, for example, on social media who post about this, who comment on this, about where the energy's been used, where it's going, how big the transfer might be at different periods of time. So just out of interest, I suggested that, or said that Highlands produces 420% of our own electricity demand. Glasgow, for example, only produces 2% of its electricity demand from renewables found within the Glasgow boundary. So you can start to see where these flows of energy are going.
Thanks very much. Feedback from Cecile. Thanks, very clear and sufficient information from a non-scientific person like me. And I've got one from David. Given the power rating quoted for a single turbine is, for instance, 7 megawatts per hour, does each one actually produce this, or is this an average?
No, that's the maximum. So if these turbines cut in at a certain wind speed, so they start producing electricity at a certain wind speed, and they'll then cut out if the wind speed gets too high to avoid doing damage. But say the 7 megawatts is the maximum amount of electricity that turbine can produce when the wind's going really, really fast. It won't produce that all the time. Quite often it will produce up to 7 megawatts at certain periods of time. Sometimes it will produce 0. What we use is the capacity factor here. So how much of its time it's spent at that rated capacity. For offshore wind, you're probably thinking around between 40, 50, maybe as high as 60 as you go out deeper. So perhaps around half the time it's producing the full 7 megawatts.
Thanks, Magnus. Garant says, excellent presentation, fascinating information, delivered in a very understandable and interesting format. Love the passion of your presentation. That's lovely. Carol would like to know, is there also a requirement for mass energy storage, e.g. grid level batteries, to match consumption with generation?
Absolutely, that's going to be the main challenge going forward as we turn all our generation renewable, or a lot of it renewable. The only way that we can really store energy at a grid scale, at a big scale, at the moment is pumped storage schemes. So this is effectively a hydro dam where you pump water from a lower reservoir to a higher reservoir. When there's a lot of electricity or cheap electricity, and then when you're needing the electricity, you reverse that flow and you use it like a normal hydro dam. There are plans for bigger or more of these in Scotland, bigger ones in Scotland, but we will need to find a new way to meet this seasonal demand at scale. One of the ways which has been mooted is creating green hydrogen and then storing that hydrogen in old gas wells under the North Sea, for example. But it will be the real challenge of our generation, is solving that problem. Whether you can scale conventional lithium-ion batteries up to that, I would disagree. I would say that you couldn't do that because of the amount of resources that you would need to take out the ground to achieve that level of demand. There's some interesting ways as well where you effectively kind of pump air to the bottom of the seabed and then hold it down there, and then when you need the electricity, you let the bubble come to the top of the sea and run it through a turbine. So lots of really smart people are working on this question.
Thanks, Magnus. Elena Bakey, one of the organisers, has put a reminder: if you've enjoyed this presentation, have missed any of the other Science Festival webinars, most of them are available as recordings on our website, www.science03.org. Dr. Michael Leach's presentation will be there only this week, so hurry. Peter Hardiman. Peter's a great friend of the festival, a support over many years. He says, excellent presentation, thank you. The multi-gigawatt scale of these developments and potential developments is awesome. I was watching an online event last week that included a presentation by Dr. J.M. Cooley, Chief Executive ITM Power, on the new factory in Sheffield to produce multi-gigawatt of electrolyzer capacity for production of hydrogen for transport, heating and chemical industry feedstock. Thanks, Peter. Thanks for the comments. If I go back to S. Ward, what is the carbon footprint of offshore renewables? There is non-renewable energy used for manufacture, transport and decommissioning. And how long does a turbine have to operate before it generates more energy than was used for manufacture, transport and decommissioning?
It's a brilliant question. I don't quite know the answer to, but if we looked at onshore wind, for example, with good onshore wind in the right areas, usually takes a year or two to pay that carbon footprint back. Because these are at sea, there maybe is less of a carbon or less carbon emissions from building, for example, carbon-rich soils. However, you are running a lot of vessels back and forth. These are big pieces of kit. Looking to the future, that carbon footprint of the turbines and the development will probably come down as the operation and maintenance vessels shift to net zero fuels or electricity themselves or hydrogen themselves. So the footprint will come down, but it wouldn't surprise me if it takes a year or two, a couple of years until for that carbon to be paid off.
Right, thanks, Magnus. We're coming to the last few questions now, Magnus. Vicky's got a couple. Could we potentially be looking at a future with just offshore turbines and be able to do away with the onshore ones, which she personally finds are more visually intrusive? Or will we end up with both? So that's part of the question. And the other bit is, Vicky says, I'm aware there are studies going on, for instance, at Oxford Brookes universities into the visual impact and tourism effects, but there seems to be quite a plan already for several to be built. Will the results of these reports be taken into consideration in the planning process?
Again, two brilliant questions. So to answer the first question, in the near future, I would expect for us still to have both. If we go back to this slide, you can see that offshore wind currently makes up quite a small proportion of that total, the total generation. It would be really nice to get to a position where we could have that, where we just put everything offshore. Whether that's technically feasible, whether that's feasible with the amount of space we've actually got to see, whether that's feasible with the amount of electricity capacity that we need to see, I'm not quite sure. In an ideal situation, that's what would happen. So yeah, in an ideal situation, that's what would happen. But I don't know if we will see that, and if we do see that, I don't know over what time frame. The second of which, it's always just really good from a scientific point of view to hear about these studies going in, particularly with tourism, which is hugely important for our local economy, and particularly for onshore wind, which is hugely important for reducing our carbon footprint. Whether these will be taken into account before these planned wind farms are built, I would suspect that they could be taken into account if they're released before that, but you would have to ask the planning committee at the council. You would have to, if it's bigger than a certain size, you would have to ask the planning officials, the government. I'm not hugely familiar with what kind of scientific studies they take into account in regards to these aspects.
Thanks, Magnus. Last two questions. Terry would like to know, can you say anything about the research on ecological impacts?
Yeah, so in terms of ecological impacts, there's a lot of studies that are ongoing. As I think I was saying, this is quite a new technology. These are new developments. We don't have data sets with 10, 20, 30, 40 years of understanding of how these interact with the environment, the ecological impact. The way that we do it is we build carefully, we monitor the whole time, we keep reviewing the whole process, we keep reviewing what's happening, we stop building if there's too much of an ecological impact. In regards to this, we're always looking at new ways, new pieces of technology that we can use to monitor these impacts. So at ERI, we're looking at how we can use drones to monitor these impacts, monitor the impact of these turbines and seabirds, and where they feed, for example. So there's a huge amount of study going on. Probably slightly less now that we've built a couple of offshore wind farms than the early days. But yeah, these are certainly ongoing studies. And after all, you would think that the developers would find these a nuisance, but the developers actually care a lot about the environmental and the ecological studies and ecological impacts, because it comes down to an economic decision in the end. If these have too much ecological impact, they won't be able to build in certain places. So they want to know what the impact is so they can try and alleviate that impact so that they can build their turbines.
Okay. Thanks. This is the last question, and then Claire will do a thank you. So David would like to know, are the turbines or their blades mostly steel, or do they use composite material?
So the towers are all usually steel. The jackets and the foundations are usually steel. The blades are made of fiberglass and composites, and they need to be quite light to be able to move around. We might just see, or I'm saying we might just see, what we'll probably see in the future is these foundations, particularly floating foundations, changing from steel to concrete, or a mix of both steel and concrete. But yeah, there's a mix of materials, with the towers being mainly steel and the blades being made mainly fiberglass or lighter materials.
Thanks very much. So I'd like to hand over, if Nicola could put Claire on for thanks.
That was brilliant. Thank you so much, Magnus. I really enjoyed that. I loved your presentation, but I think I loved the Q&A just a little bit more. There's some really great questions, everyone. Thank you very much for that. So if you'd like to follow Magnus, you can find him on Twitter at @DavidsonMagnus, or you can go on to Facebook and follow the Caithness International Science Festival, or maybe you'd like to visit our website, where you can download this magnificent book. Yeah, I think just from what I've seen, children are great, children are fantastic, but if by any chance you want 20 minutes of peace, I really, really recommend this. You can find these in the some of the supermarkets in Wick and Thurso, or you can download your own version here. So just a little shout out to this magnificent book that the magnificent Nicola put together. Thank you, Nicola. But that's not all. We have more online events. Tomorrow night, Thursday the 25th, we're joined by Dwayne Carey and his wife, Cheryl. Dwayne Carey is, of course, a former astronaut. So if you would like to see the more personal, more family-oriented, more interesting question and answer, if planets aren't particularly your thing, I don't think that would apply to anyone here, but I'm just saying, if you want to learn the highs and lows of serving your world with pride and keeping it all together while raising a family, this is the place to go to. On Friday, we also have two events, a live dive with Macduff Marine Aquarium at 2 p.m. And then at 7:30, we're joined by Martin Murray, owner and master distiller at Dunnet Bay Distillery, who will tell us all about the production processes and how he selects the botanicals used in their award-winning spirits. So you can find out full details for these events and the rest of the festival at science03.org. Thanks again for joining us, and we hope you enjoy the rest of the 2021 Caithness International Science Festival. Goodbye, everyone.